Today we'll be talking about powers. What is a power? A power consists of two parts. This is called the base, and this is called the exponent. Together, it's 2 to the exponent 3, and this is a power. Now, in order to use powers, there are certain rules we need to go by. First of all, we need to understand what this means. What is the relationship of this exponent to the base? It means that we are taking the number 2 and multiplying it by itself 3 times, and that equals to 8. If you have 2 to the 4 and you want to expand that, you would say 2 times 2 times 2 times 2, and that would equal to 16. And that's how the exponent affects the base. The number of times that you're going to multiply the base by itself. Now, there are a lot of great things we can do with powers. We can multiply powers. And I will show you how we can do this. For example, if I have 2 to the exponent 4 times 2 to the exponent 3, it's as though I am saying 2 times 2 times 2 times 2, and then multiplying that by 2 times 2 times 2. If I look at all this, how many 2's do I have? That will equal 2 to the exponent 7. Another one we can do is this. And that means A times A times A, and then multiplied by another A. As you notice, this one here doesn't have an exponent. However, the fact that there is one, we can imagine an imaginary one there. You don't have to put it, but you have to remember to take it into consideration. Now, when I look at this, this gives me A to the 4. Have you noticed anything by what we've done? Rather than expanding, that would take a lot of time. We can look at the exponents and do what? 3 and 4 gives you 7. 3 and 1 gives you 4. And this is our rule. When multiplying powers, add the exponent. But there is a rule. If and only if the bases are the same. And that is very, very important. If the bases are not the same, then you would do something like this. I will show you. If we do not have the same base, then you would say, for example, 3 squared times 2 cubed. That would be 3 squared, and we would figure out what that is. 3 times 3 is 9, and then this is 2 cubed, which is 2 times 2 times 2, which is 8. I should show you the expanded form just so that you can see where I got that from. Maybe I went a little too fast, and here we go. That's our expanded form. And then I would multiply these two and get 72. I cannot add these two exponents because the bases are not the same. That is an important rule. Okay, so let's try a different one. What if we had a cubed, b squared, and then we multiplied that by a squared b? Now here, the bases are not the same. So what we do is we look for those that are the same. And this a and this a have the same base. This b squared and this b to the exponent 1, remember there's a 1 here, they have the same base. So we can take care of these one at a time. A cubed and a squared times a squared is a to the exponent 5. B squared times another b is b3. Let's do one more to make sure you understand. X to the 4, y to the 7, x to the 6, y2. Right? And now we've got x to the 4. Let's add these two. They have the same base, the x's. That is x to the exponent 10. y7, y squared, is y to the exponent 9. And now you have learned how to multiply powers. Let's try to do the division of powers and find out what is that about. Dividing powers. Now, dividing powers, let me show you something. If I have 3 to the exponent 4 divided by 3 to the exponent 3, and I wrote it out in expanded form, 3 times 3 times 3 times 3, and I divided it, and this is a division just as this one is. It's the same thing, and I divide by 3 times 3 times 3. The way you would normally have done this, you would divide 3 by 3 and you're left with 1. 3 goes into 3 once, and this 3 goes into 3 once, and I am left with 1 3. The answer is 3. I can keep doing this, but do you notice this is 3 to the exponent 1. You know, I haven't put the 1 there, but it is always there because we can see there's a 3. Let's try another one. 4 squared divided by 4 is 4 times 4. Now let's make it, let's change this. Let's make this into a 4 and this into a 2. And so that's 4 times 4 times 4 times 4 over 4 times 4. And again, I can cancel these out because they're divisible. They divide into each other by 1. And then how many am I left with? 2 of them. Instead of writing 4 times 4, I can write 4 to the exponent 2. Do you notice anything about these? Well, simply, I can subtract the exponents. And again, only if the bases are the same. So let's write out this rule. And let's have a little bit of fun with this. So dividing powers, subtract the exponents. Again, if and only if, this is a very important statement, the bases are the same. Okay, and so now let's try another example. If I have 6 to the exponent 8 divided by 6 to the exponent 5, I could just subtract these two exponents. Why? Because the bases are the same. That gives you 6 to the exponent 3. You see that? A to the exponent 10 divided by a to the exponent 7. Again, we can subtract and we get a to the exponent 3. X 7, y 6, and z2 divided by x to the exponent 5, y to the exponent 4, and just 1z. What would that be? Well, again, we must take them one at a time because they are not the same. The entire thing is not the same as this one here. So 7 minus 5, x squared, y6, y4, subtract the exponents, y to the 2. Z2 and Z1, remember there's a 1 here, leaves us with only 1z. Okay, very good.